All right, welcome back. So, if you haven't checked out our other video, take a look at that one. We look at how does temperature affect weathering. Now we're going to take a look at how does the amount of surface area exposed affect the weathering of rock. And to do that, we have the same materials as earlier. We have a cup of water. So water straight out of the faucet will work just fine. Room temperature water works perfect too. We're going to keep the same temperature water. So I have a nice bucket here of plenty of water to switch out. We also need 3 Alka-Seltzer tablets, a timekeeping device, and somewhere to record our data. So we're going to record our time in seconds. And what's different about this experiment is we're going to break up these tablets more and more each time we try. So we're going to start with a whole tablet, then we're going to break one up into 4 pieces, and then we're going to crush one up into a powder. So let's go ahead and start. So regular, normal, room temperature water, we're going to drop our first tablet in, representing a rock, and this process represents just normal weathering. So once the bubbles stop, we are going to stop our time and record our results. All right, still got a little bit of bubbling going on. And I'm going to go ahead and stop it right there. All right, so 33 seconds for a whole tablet. All right, 33 seconds. All right, so we're going to take this water and get fresh water in our cup. Dump that out. Add some brand new water. Right about the same area there. And this time we're going to take a tablet and we're going to break it up into 4 pieces. So we're adding more surface area. We're exposing more surface area this time. So we'll just break in half. There we go. And as you see, we have 4 pieces. So we're going to drop all 4 in at once and then record our time again on our table. Right. Ooh. A lot faster than last time. And I'm going to go ahead and stop it right there. All right, so this one is 28 seconds. All right, 28 seconds. And we're going to take our water, dump it out, brand new water for our last trial. Swirl that around. Got a little bit left over in there. And brand new fresh water. All right, so this is the fun one. We get to take this tablet and we get to crush it up into a powder. So I'm just going to put it inside of this paper towel so I don't make a mess, and I'm going to go ahead and crush it up. So use a marker, use your fist, whatever you have. All right. So I have thoroughly powdered that. This is always a fun one to do. All right, so now we have a full powder. I'm going to take all that powder and at one time I'm going to dump it in. Timer. And go ahead and start. All right, there we go. So remember, we're going to stop the time once the bubbles stop. And that was quick. That was 15 seconds. All right. So now that we have our time over here, we see that as we start to expose more surface area, and by doing that here in our experiment, we just broke the tablet apart. So as we expose more surface area, we can tell that our rock, our tablet, weathers much more quickly. So think about, where could we see this type of weathering occur out in real life? So an idea that I brought up in class is, what if we had a gigantic boulder or a small pile of gravel, very, very small gravel? Which one do you think is going to weather faster, the boulder or the small pile of gravel? So think about that. All right. So if you have watched our video on temperature, so this one covered surface area, if you were to combine our thoughts on temperature and surface area, where in the world do you think we would find an area that has more rock weathered due to temperature and surface area? All right, I'll see you at the next video.